Okay, carrying on to page 3. The aim with these is still very much to get them equal to 0 before then factorising them. So to make this equation equal to 0, we're going to have to get rid of this x squared here. We have the fewer amount on this side, so we're going to subtract x squared from each side. That will leave us just 1x squared over on the left. It's not going to affect our x's or our constant, and that will give us 0 on the right. Now it's ready to factorise. Looking for two things which times together to make 49, add together to make negative 14, and that one is negative 7 in each bracket. So this could also be written as x minus 7 all squared equals 0. So there's only one solution, and that is x is 7. On E, where do we have the most x squareds? That's actually on the right. Confusingly, because they're both negatives, but this is the smallest negative. So if we add 2x squared to both sides, I'm just going to list the things that we're doing up here. So we're going to add 2x squared. That would give us a positive 1x squared there, and it would get rid of those on the left. We're then also going to, seeing as we've decided we're going to keep all of our quadratic over on this right hand side of the equal sign, we're going to get rid of this x by subtracting x from both sides, and that would give us minus 6x now. And we're going to get rid of this negative 1 by adding 1 to both sides, and that would give us plus 9. And now we've got 0 on the left. When we factorise this, this is similar to the last one, because it's x minus 3 times x minus 3, or x minus 3 all squared. Of course, squared just means times by itself. So there's only one solution to this one as well, which is x equals 3. We call this a perfect square, where we have just one bracket, which you can just put a squared sign outside of, that would make this quadratic. Okay, on F, we have the most x squareds on the left, so that's where we're going to collect everything. In other words, we need to subtract 10x squared, leaving us 1x squared on the left. We are going to subtract our x, and we don't have any over here, so that will just give us a negative x. And we're going to subtract 105. Don't think automatically that that's going to disappear, because that's already a negative 105, so we're actually going to have negative 210, and that will be equal to 0. You can kind of narrow down your factors to find out what these numbers are. Because you know they're going to have a difference of 1. If we've got a 1 in front of the x, looking for two factors that times together to make 210 with a difference of 1. So it's not going to be 21 and 10, it's going to be something between those numbers. So if we think about what goes into these, maybe 15 and something, 15 times 7 would be 105, so 15 times 14 would be 210, yeah, and they have a difference of 1. And we want them to have a difference of negative 1, so we're going to have minus 15 plus 14. Sorry, you can't have a difference of negative 1, but you know what I mean. We want them to add together to make negative 1, so the 15 needs to be the one with a negative. So our solutions here are x equals 15 and x equals 14. Okay, moving on. Getting a bit harder now, involving some fractions. If we want to eliminate a fraction, a denominator, from an equation, we need to times to get it out from being a denominator. So here we're going to times both sides by x minus 4. Now that will just eliminate it from that side, but things rarely just disappear in algebra. It will, as soon as we have to times the other side by x minus 4, this is what we would end up with. And you can see there that that's what gives us our quadratic here. So when we multiply out this bracket, which we need to do, by the way, it might already be factorised, but this is not equal to 0. We need to multiply out this bracket, simplify, and then refactorise. So that's going to give us x squared when we times the x by the x. Remember, using FOIL here. Outer ones would give us minus 4x. Inner ones would give us minus 2x. And last times last would give us positive 8. And then when we simplify and get it all equal to 0, we're going to remove that 3. We're also going to combine these into one term, which will be minus 6x. And when we take away the 3 from the 8, we're going to have plus 5. And then we're going to factorise. Looking for two numbers at times together to make positive 5, add together to make negative 6. So that's going to be negative 5 and negative 1. So x is equal to 5 and x is equal to 1. Similar process on part B. We need to times, but we need to times twice this time to get rid of these denominators. If we times everything by 4, that would just give us x plus 3 on that side. We've eliminated this denominator. But the 4 would times by this fraction, and it would specifically only times with the numerator here. It wouldn't times by both parts. That would just give us an equivalent fraction. So when we times a fraction by a number, we're only timesing the numerator. So 4 times 3 would give us 12. But we've still got that denominator there. Okay, to get rid of that denominator, we need to times by x minus 1, both sides. And that will now give us x minus 1 times x plus 3, so a double bracket over on the left equals 12. So we need to do similar to the last question, expand out x squared. Now I'm going to simplify, I'm going to just jump this step here. The more of these you do, the quicker you get at it. You can automatically see that these are going to combine to make negative 6x, and you can start to do that at this stage rather than having to write them out separately. So whatever these two add together to make will become that middle term. It's actually the same process as factorising but in reverse. So these will add together to make plus 2, positive 2, so that's going to give me positive 2x, and they will times together to make negative 3. Then need to get rid of the 12. So if I take away 12 from both sides, that will give me minus 15 equals 0. And then factorise, running out of space here. 5 and 3 are my numbers, and I want to have a plus 5 and a minus 3. So my solutions are x equals negative 5 and x equals 3. Just highlight my answers here. Okay, and the last one. Now this one's quite tricky to think about what to do here. You could maybe times by x squared and then by x, but actually you don't need to, and I'll show you a quicker way to do it. X squared is a multiple of x anyway. The easiest thing to do here is to times by x squared, and if you like, that is the lowest common multiple of these two denominators. Okay, they both go into x squared. So when we times this first term by x squared, we will just get 45. When we times the next term by x squared, we will get 4x squared over x, and hopefully you can see that this will simplify down. X squared divided by x will just give us x. Okay, so I'm just going to get rid of that now. Oops, I'll just leave it as 4x. And when we times negative 1 by x squared, that's going to give us negative x squared. And there you go, just in one step we've got rid of all the denominators. I'm just going to rearrange this now to make it a positive x squared so that it factorises easier. And to do that, I'm going to move this x squared over to the other side of the equal sign, so it's going to become positive x squared. I'm going to move everything over to the other side of the equal sign, actually. Basically, swapping sides here. So positive x squared, everything's going to change sign. This is going to become plus 4x, and that constant is going to change to a negative 45, and then we're ready to factorise. So two numbers that times together to make 45, add together to make 4, that's going to be plus 9 and minus 5. So x is negative 9 and positive 5. Okay. Alex is W years old. His sister Claudia is 3 years younger than Alex. So Alex is W. Claudia is w minus 3. The product of their ages is 180. So product means multiplication. So w times w minus 3 is 180. There's a quadratic. I'm going to expand it out just to show. W squared minus 3w, 180. Just going to bring it up here and make it equal to 0 by subtracting 180 from each side. And then we're ready to factorize. Okay, so looking for two numbers that times together to make 180, add together to make negative 3. So I'm thinking 16, 3, no, those are too far apart. What else have we got? We've got 20 and 9. And 12. 15 and 12. So it's going to be minus 15 plus 12. So my solution is w equals 15 or w equals negative 12. Sorry, I've just read that that part of the question was just to set up an equation, not actually to solve it. That was part B. So we've just done part B here. That's all right. Now, which one of these could not be Alex's age? Well, somebody can't be negative 12 years old. And sometimes this happens with quadratics. We get an answer which isn't possible. So we're just going to ignore that answer. Okay, it is a correct answer that solves the quadratic, but it isn't a possible answer for Alex's age. So the answer is 15. Okay. Right, number 9. A rectangular field is 10 meters longer than wide. So if we call its width w, and we call its length w plus 10. And it says the area of the field is 2000. So the area, remember, we get when we times length by the width. So very similar to the question above. I'm going to expand out that first expression. We're then going to get it equal to 0, so we can refactorize. Okay. Looking for two numbers that times together to make 2000, add together to make 10. So 210. What else have we got? 40 and 50. So that's going to be plus 50 minus 40 in the other bracket. So the width is equal to either negative 50 or 40 meters. And we can't have a negative width, so we're going to ignore that one. It's important if you're ruling out an answer that you still make it visible, but clearly identify which one is the actual answer. But this question says it wants the perimeter of the field, not just the width. So we then need to substitute this back into a formula that would give us the perimeter. There's many different ways you can think about finding the perimeter. To keep it simple, I will just do 2 lots of the width and add on 2 lots of the length. Now if the length is the width plus 10, that's going to be 50. So this is going to give us 180 meters perimeter. Okay, number 10. Triangle has an area of 85 square centimeters. The height of the triangle is 7 centimeters longer than the base. So if the base is B, then the height is going to be B plus 7. And how do we find the area of a triangle? We do the base times the height, we times by half or divide by 2. Okay, we're going to use this to make our equation. So we're going to times by 2, and I'm going to expand out that bracket in the same step. So b squared plus 7b. And when I times by 2, that 2 disappears from being on the denominator, and it's going to multiply by 85 to give me 170. Let's get it all equal to 0. Okay, so two numbers that times together to make 170, 17 and 10, and that would work here to give me a 7. So if I want to get a positive 7 from those numbers, I need to do a positive 17 minus 10. So that gives me a value for the base of negative 17 or positive 10. And it's got to be positive 10, hasn't it? We're going to ignore that one. It's not a possible length. Can't have negative length. But it wants the lengths of the height as well. So that's the base. And the height, if it's 7 centimeters longer, is 17. Okay, and the last question on the page. Two positive numbers which have a difference of 3 are squared. The difference of the results is 81. So if I call my larger number x, and my smaller number x minus 3, because the difference is found by subtracting, then I can do this question. So those numbers themselves are squared. So if I square this, that would give me x squared. And if I square this one, just going to think a little bit harder about this one, that would give me x squared minus 6x plus 9. So a lot of people would be tempted to just put x squared minus 9 or plus 9. But don't forget there would be this middle term. If you do FOIL, I'm not going to go through expanding double brackets much going forward, so this should be a skill that's under the that's in the tool belt already. Now it says the difference in the results is 81. Now when you square a smaller number, you're going to get a smaller answer, as long as we're not talking about negative numbers here. So x squared minus all of this is going to give us 81. Now when we minus all of that, we've got to be very careful. Just going to keep it in a bracket for now, just so I can write it down as it is. But when we minus everything, let me show you what happens. Oops. The x squared here, take away this x squared, give us 0x squareds, no x squareds. If I take away negative 6x, think about that double negative that's going on there. I'm taking away something which is already negative. That's going to give me positive 6x. And when I take away positive 9, that's going to give me negative 9. So that's what I'm left with. That's a simple linear equation to solve. So I'm just going to add 9 to both sides. 6x equals 90. Divide by 6. So x is 15. Okay, x is 15. The other number was x minus 3. So the smaller number was 12. Okay, so my answers are 15 and 12.